In this lecture, you'll learn about SnapVault, which is ONTAP's disk-to-disk backup solution. I will tell you about the benefits of SnapVault, show you how to configure it and how to use custom policies, and also how to do restores. SnapVault is ONTAP's long-term disk-to-disk backup solution. So what it does is it replicates data from a source volume to a destination volume. And in the destination volume, you're going to have snapshots there, which are used as long-term backups going back in time. You can also use it to offload tape backups from remote systems to a centralized cluster. I've got some diagrams of this being used coming up in a second. It has the same functionality as traditional tape backups, but it is much faster, way more convenient, and requires less storage space. Data is replicated from the source volume to a destination volume on a centralized backup cluster. So looking at a difference between SnapVault and SnapMirror. With SnapMirror data protection mirrors, there's typically two snapshots maintained on the destination volume. When replication occurs, the oldest snapshot is deleted. The new snapshot is compared to the previous one to determine the incremental changes to replicate. So with SnapMirror DP mirrors, it keeps the source and the destination volume in the same state, keeps them synchronized with each other, with possibly some delay depending on what your replication schedule is. But with DP mirrors, you cannot use them as a backup solution because it keeps the destination current with the source. It doesn't have older data there going back in time that you can back up from. Unlike DP mirrors, SnapVault can retain multiple snapshots as backups over a long time period. So DP mirrors is your disaster recovery solution. SnapVault is your backup solution. So looking at this with some diagrams now, you can see we've got the sources over here on the left. We've got 3 different ONTAP clusters, which are probably in 3 different physical locations. And from there, we are backing them all up to one centralized SnapVault cluster. You can also use SnapVault for staging to remote tape. So here we've got the same 3 sources again. We are backing them up to the same destination cluster again. And from there, we are then backing them up to tape. So typically, it would be more convenient if we were just backing them up to disk on the destination cluster. But if you have got regulatory compliance, which means that you have to back up to tape, then you could use this solution here. The source and destination systems do not need to use the same hardware. So you can use inexpensive SATA disks on the destination volume. So going back a slide again, so over here on the left, these are our production clusters, which are being used for our in-use data. And if we require a higher performance there, we would be using SSD or possibly SAS drives. Over in the destination on the SnapVault system, we don't have clients accessing the data there, so we don't need to use high performance drives. And there's a good chance we're going to want a lot of capacity there to store those backups going back over time. So we can do that in the most cost-effective way by using the SATA drives there. Okay, moving on. SnapVault replication uses the SnapMirror engine, so the replication works in the same way as it does for the SnapMirror DP mirrors. We have the initial baseline transfer first, where a SnapMirror snapshot copy is created of all data on the source volume, the snapshot copy and all the data blocks it references, and optionally other non-SnapMirror snapshots are then transferred to the destination volume. After that initial baseline transfer, updates can be performed manually or, by far more commonly, using an automated schedule. A new SnapMirror snapshot copy is taken and transferred to the destination based on the schedule. The current SnapMirror snapshot copy is compared with the previous SnapMirror snapshot copy, and then updated blocks are replicated from the source to the destination. So after that initial baseline transfer, it's just the incremental changes that are going to be replicated across. So let's look at why SnapVault is better than traditional tape backups. Well, traditional tape backups and restores are slow. They require the media to be physically unloaded from the tape device as well, and then transported off-site and securely stored and catalogued after backups. That is a load of hassle from an administrative point of view. And if you need to restore data, the tape media needs to be found and then transported back on site. And again, doing the actual backup to tape and also the restore from tape is a slow process. So it's very slow and there's a lot of hassle, a lot of admin overhead with it as well. If you don't have a long enough time window on weeknights to back up your data, then you're probably going to be taking full backups on the weekend and incremental backups on weeknights. And if you need to restore a data set, you'll need to restore from the last full backup and then every incremental. So let's say, for example, using traditional tape backups, you have a problem with a volume on Friday. You need to do the restore on Friday, but the last full backup was on Sunday. Well, in that case, you would need to get the full backup tape from Sunday and also the incremental backup tapes from Monday, Tuesday, Wednesday, and Thursday and do a restore from all of them. Very slow, very inconvenient process. So let's look at how things are better with SnapVault. Well, with SnapVault, only incremental changes are replicated to the secondary always after that initial baseline transfer, but each snapshot appears as a full backup for restores. So if you do need to do that restore on Friday, you just do the restore from the snapshot on Thursday night. You don't have to go back over multiple incremental backups to get there. Also, storage efficiency space savings are retained if you're using deduplication and compression. So because of this, backups can be completed in a much shorter time window, and the capacity requirements can be 90% lower than using tape. So it's all good, it's much more efficient, and things are just much easier from the storage administrator's perspective as well. Data can be restored from SnapVault secondary volume with less downtime and uncertainty than traditional tape restores. If you're getting a tape out of cold storage somewhere, then hopefully the tape's still in a good condition, but you're really not going to know until you try to do the restore from it. With SnapVault, there's no physical media to load, unload, and transport off-site and then back on site again. For the terminology, the source system is known as the primary, and the destination is the secondary. Data can be restored from the SnapVault secondary volume back to the associated primary volume or to a different volume. So in most cases, you will be restoring back to the original source volume. For example, if a file or folder was accidentally deleted, you would be restoring back to the original source volume. But if you had some kind of more serious event, like if you had a fire or a flood, and you've actually lost the original source cluster, then you can still restore back to a different cluster, so you can still get that data back. And the entire volume or individual files, folders, and LUNs can be restored. Looking at how SnapVault works now, we need to do some configuration on the source side, and we do some configuration on the destination side as well. We're going to be taking snapshots on the source system, and this is our normal standard snapshots where we're going to be using them for short-term, convenient backup and restores. So we don't want to be taking and retaining too many snapshots on the source system because we would take up too much room there. Those snapshots that we're taking on the source system are then going to be pooled over to the SnapVault system. But the difference is we're going to keep more of them there going back further in time for our long-term backup. So looking at the first part of this, on the source side, we're going to have a snapshot policy applied to the source volume on the primary source cluster. This is a standard snapshot policy, the same as is used for normal scheduled snapshot copies on the source volume, the same as we covered in the snapshots section. And like I said, on the source volume of snapshots, you're going to want to retain them for a short period of time there so that they don't take up too much room. Now, the one difference when you're using SnapVault is that you're going to apply a label to the snapshots that you're taking on the source volume. So a SnapMirror label is applied to those scheduled snapshots. The label would be, for example, a label of daily on your daily snapshots and weekly on your weekly snapshots. On the SnapVault side, you're going to have a policy there that is going to look for snapshots in the source side, and it's going to pull them across. So you could, for example, on the source side, be taking snapshots daily and weekly and keep 5 daily snapshots and 4 weekly snapshots. And then on the SnapVault system, you're going to be looking for those same snapshots. So they've got a label of daily and weekly, but you're going to keep maybe 30 dailies and 52 weeklies. So on the source side, you would have snapshot backups going back for a week. On the SnapVault destination side, you would have those same snapshots, but you would keep them going back a year for your long-term backup. So that was the snapshot policy on the source side. On the destination side, on the SnapVault system, we're going to have a SnapMirror policy. That is applied to the destination volume on the secondary SnapVault cluster. The policy contains rules which contain snapshot mirror labels and how long they should be retained for. So using that same example again, it would be looking for the labels of daily and weekly, and it would specify to keep the dailies for 30 days and the weeklies for 52 weeks. The secondary cluster pulls snapshots with matching labels on the source to the destination volume. And because this is used for our long-term backups, it's the same snapshots, but we're going to keep them for longer. So looking at the actual configuration now, it's the same initial configuration as we had for our SnapMirror DP mirrors. So first off, we have to license SnapVault. If you're using a later version of ONTAP, the SnapMirror license covers you for SnapVault as well. If you're using an old version of ONTAP, then you do require a specific SnapVault license. You then create your intercluster lifts on every node on both clusters, peer the clusters, and peer the SVMs. I covered that in more detail earlier in this section. Then we're ready to configure our snapshot policy on the primary source cluster. So working through an example here. On the source system, we say snapshot policy create. The vServer for our example is department A. And in the policy, we've named it to weeks. And then you have to say enable true. So this command's quite unusual. Normally, commands will be enabled by default, but when you create a snapshot policy, it's not enabled by default. So you do have to explicitly say enabled true. Then you specify the snapshots that you're going to take on the source side and how many of these you're going to keep. So here I've said schedule 1 is hourly. So based on a cron schedule that I've got configured on the system, I'm going to be taking snapshots every hour. Then I say count 1 is 5. I'm going to keep the last 5 of those. So you see here, I've got schedule 1 and count 1. The number 1 ties those two together. So I'm saying I'm going to keep 5 of my hourly snapshots. Then I'm going to do schedule 2. So as well as hourly snapshots, I'm going to take daily snapshots as well. Count 2 is 5, so I'm going to keep the last 5 of those. And because I want to pull these over to my SnapVault system, I say SnapMirror label 2 daily. Again, these are tied together by the number 2. So I've got schedule 2, count 2, and SnapMirror label 2. And notice here that for the daily snapshots, I put a SnapMirror label on there because I want to pull them over to the SnapVault system. In our example here, I don't want to take those hourly snapshots over because it's really just the long-term backup I've got on my SnapVault system. So because I'm not going to be pulling the hourly snapshots over, I don't need to put a SnapMirror label on there. And then finally, I'm also going to be taking weekly snapshots as well. So I say schedule 3 weekly, count 3 2. So I'm going to keep the last 2 weekly snapshots. I'm going to want to pull these over to my SnapVault system as well. So I say SnapMirror label 3 weekly. And there you can see I've got schedule 3, count 3, and SnapMirror label 3. So the 3 ties those together. Notice here on my source side, I'm taking hourly and daily and weekly snapshots, and I'm keeping snapshots for a time period of up to 2 weeks. I then need to apply that to my volume. So I say volume modify. This is for vServer department A, volume 2, and I say snapshot policy 2 week. So that is everything I need to configure on the source side, apart from the initial setup of the peering. So now I'm ready to configure my SnapVault system, the destination side. And here you can use one of the system policies, but if none of those system policies has an actual schedule of what snapshots that you want to keep, then you'll need to create a custom policy as I'm doing here. So on the secondary, the destination side, I've said SnapMirror policy create. This is for vServer department A_SV on the destination cluster, and I've named my policy vol2. Then I say SnapMirror policy add rules. It's with the rules that you add to the policy that you specify the snapshots that are going to be pulled across and how many of them you're going to keep. So in here, I've said that it's for vServer department ASV, and the policy is vol2, the policy I just created. And then I say SnapMirror label daily, keep 31. So on the source side, when it takes daily snapshots, it's going to put that SnapMirror label of daily on there because we configured that on the source side. On the destination side, it's going to look for snapshots that have got that label of daily. It's going to find them, and whenever it finds any new ones, it will pull that across, and it's going to keep the last 31. So you saw on the source side for our dailies, we were going to keep 5 of those. On the destination side, because it's our long-term backup, we're going to keep 31 of those. So we're keeping more snapshots going further back in time on the SnapVault system. We also want to pull over the weekly snapshots as well. So we're going to add another rule to our policy. We say SnapMirror policy add rule. Again, it's vServer department ASV, the policy of vol2. And we say SnapMirror label is weekly. That's the label we're looking for. Whenever we find a new weekly snapshot, we're going to pull that across to the destination, and we're going to keep 52 of those. So that would be going back for a year. Okay, next thing is the SnapMirror policy rule schedule commands. This is another rule that you can add to your policy. So you can create snapshots directly on the destination volume. This is useful where you don't want to retain those snapshots on the source. I'll come back and I'll explain that further in a second. But let me show you the command first. So here, going back just one slide. So here, I'm going to add another rule to this policy that I had already created. And I'm going to say job schedule. First off, I need to have a cron schedule. So when you looked at these, I had my daily snapshots and my weekly snapshots. Those are system cron schedules. So they're already in the system anyway without you having to configure anything. Here, I'm going to first off create a custom cron schedule because I want to also have yearly snapshots. And there is not a system yearly cron schedule. So I'm going to add this myself as a custom schedule. So I say job schedule cron create. I'm calling it yearly, and I'm saying the time that I want to run this at is in the month of December, day 31, and at 59 minutes past 11. So this is going to just run one time a year at 1 minute to midnight on the last day of the year. Then I'm going to add this to my SnapMirror policy. So I say SnapMirror policy add rule. Again, it's the same policy I'm adding it to for vServer department ASV. Policy is vol2. And I say SnapMirror label yearly, keep 7. And then the difference is I say schedule yearly. So when you use the schedule command, what that does is it actually creates the snapshot directly on the destination system rather than looking for a matching label on the source and pulling it over. So what we're doing here, what this destination system will do is when this runs, it will take a snapshot based on the current data that it has got in that volume. It's going to take a new snapshot then. And the reason I'm doing this is I don't want to have a yearly snapshot on the source system because the older that snapshots get, the more space they take up. So I don't want to have a yearly there that is going to be taking up space for a whole year. Well, a way that I can do that is I just create it directly on the destination system. So let's have a look back and summarize everything that is going to happen here now. Going back to the snapshot policy on the source side on the primary cluster. Over there, we're going to take hourly snapshots every hour. We're going to keep the last 5 of those. We're not putting a SnapMirror label on them because we don't want to pull them across to the SnapVault system. We're also taking daily snapshots and keeping the last 5 of those. and we're taking weekly snapshots, and we're keeping the last 2 of those. We do want to pull those over, so we've given them a SnapMirror label. We've given them a descriptive label of daily and weekly. Then on the SnapVault side, we've created a custom policy. We've said look for snapshots on the source, which have got a label of daily. Whenever you find a new one, pull it over, keep the last 31 of those, and also look for snapshots that have got a weekly label. When you find those, pull them over and keep the last 52 of those. And then we've also said, also take a snapshot once a year, just before the time of New Year, and keep 7 of those. And that is only happening on the destination side. We don't want to have yearly snapshots on the source. So we have got our short-term snapshots on the source cluster. We've got our long-term snapshots for our long-term backup on the SnapVault system. Okay, so that is the policy done. Now what we need to do is actually create that SnapMirror relationship between the source and the destination volumes and initialize it to do the initial data transfer. So first off, we need to create the destination volume. So on our secondary SnapVault system, we say volume create for vServer department ASV. The volume that we're creating here, we're calling it volume2_SV. Specify the aggregate to put it in and the size, and we say type DP. So even though this is SnapVault, when we create the volume type is type DP. That makes it a read-only volume, and it enables auto-grow in there. Now, while I'm talking about the size of the volume, you are going to have snapshots going back over time here, which can grow to a large size. So when you're creating that volume and the sizing the aggregate that you've got volume in, make sure that you've got enough space there to keep all of your backups. Then we need to create the relationship between the source and the destination volumes. So the same command as we used for DP mirrors, we say SnapMirror create, specify the destination path with the destination SVM name, and then a colon, and then the destination volume name, and then the source path with the source SVM name and the source volume name. Then for SnapVault, the type is always XDP. Specify the policy that you just created, where you're specifying what snapshots you're going to pull over and how long you're going to keep them for, and then specify your schedule. So if you're thinking here, but wait a minute, I've got in my policy how often the snapshots are being taken and how long that I am keeping them for. Yeah, that's what's configured in the policy. What the schedule does here is it says how long it's going to connect to the source system and check for new snapshots. So because in this example, we're going to be pulling over daily snapshots as frequent as we get, we only need to check once a day, so we're going to use the schedule daily for that. And then finally, we need to do the initial baseline transfer. The command for that is SnapMirror initialize and specify the destination path that the data is being replicated into. Okay, so that was the whole command there. That's when we have it split into 3 different commands, which was creating the volume and then creating the SnapMirror relationship with the SnapMirror create command and then doing the initial baseline transfer. You can also use the newer command of SnapMirror protect, similarly to how we could use this for our SnapMirror DP mirrors. So the command syntax is the same again. We have SnapMirror protect, specify the path list. So here you can have it configure more than one volume at a time in the same command. This is a wildcard, so I'll use the same example again. If you had volumes named vol1, vol2, and vol3, you could specify the SVM and then say colon volume. Because they each start with vol, they're going to match that wildcard, and it would create a SnapVault relationship for all 3 of them. So you can do it for multiple volumes, or you can do it for just one volume with the SnapMirror protect command. Specify the destination vServer, specify the policy you're using, the schedule you're using. If you want auto initialize to be used or not, it defaults to true. You normally want to use that. And then the destination volume prefix and the destination volume suffix. So if we were doing this for our 3 volumes, vol1, vol2, and vol3, we could use the destination volume suffix of _SV for SnapVault. And on the destination side, it would create 3 volumes, volume1 _SV, volume2 _SV, and volume3 _SV. So the SnapMirror protect command, it ends up doing exactly the same as when we did it in 3 different commands. It just makes it a bit more efficient because we can use one single command to do it there. Okay, the last thing to tell you here is how to do data restores. And when you do a restore, the commands are done on the system that you're restoring the data to. So when you configured the SnapVault relationship, that was all done on the SnapVault cluster, apart from when you did the snapshot policy on the source side. When you're restoring data, it's not done on the SnapVault system, it's done on the system that you want to restore the data to. So here we are going to be restoring some data back. The command is SnapMirror restore. Specify the source path. So that is the source SVM and the source volume on the SnapVault system. And then the destination path. This is the destination SVM and the destination volume that you want to restore to. And then you can save source snapshot and the snapshot that you want to do the restore from. This will restore the entire volume. If you don't specify the source snapshot, it will use the most recent one by default. While it is doing the restore, the destination volume is going to be taken offline temporarily just for the time of the restore, and then it will be back online again. Because you're restoring the entire volume, obviously you couldn't have the volume actually online and available while you were doing that. Okay, so that's how to restore the entire volume. You can also restore individual files or folders or LUNs. It uses the same command. So we say SnapMirror restore again. Again, we specify the source path, the destination path, and the snapshot. And we just add one extra option here where we say the file list, and then you specify the path of the files that you want to restore. You can leave a space between them and restore multiple files at the same time, as we're doing here. So here we are restoring file 1 and file 2 in the finance folder. Thanks for watching. If you want to get hands-on practice with NetApp storage for free on your laptop, then you can download my free ebook, which you can see above my head right now. Also check out my NetApp Storage Complete course, which will teach you everything you could possibly want to know about ONTAP. Thanks.